Hello. So in this video, we are going to be covering the properties of logarithms. And in fact, the goal is going to be to show you that all of these properties, which you may have learned as rules or laws, which is sort of a whole other thing. I'm not going to go into that on my pedestal. But these properties of logarithms actually all come sort of from the definition of logarithms. These are not things that are sort of defined to work this way. These are things that have to work this way. So with that sort of in advance, I will say I'm going to show you the sort of reason why, sort of going through it, and then I'll give you the sort of end result properties stated afterward for each of these things. So property 0, which this is just how logarithms are defined, so I'm going to just sort of write this as the starting point. So property 0 is that if you have some b to the x, then the inverse is log base b of x, meaning that logs are defined as the inverse of the exponential. In particular, this means that if I take log base b of b to the x, right, if I take the inverse statement, which is log base b of the input, but I input that b to the x, I just get back x. But again, importantly, with inverses, it goes the other way, right? So if I take b to the log base b of x, that's what would happen here, that also gives me x. Right, so these things undo each other no matter which way you're going. So again, here, the top one that's saying, okay, log base b of b to the x is x, and the bottom one saying b to the power of log base b of x, that is also x. So this is just the definition of logarithms. We've sort of already stated it, but to be very clear, sort of starting from this location for all the rest of the properties. All right. So with that established, let's now look at our next property. This is going to be arguably the sort of weirdest one, mostly because I have to work from property 0, which is a weird property to work from. So this one will be the worst of alphabet soup to sort of keep track of. All the rest should be pretty easy. I hope. That's the dream. So if I'm looking at something like, so to be clear, I haven't stated the general property yet. If I'm looking at something like log base b of a thing plus log base b of another thing, and I want to have that equal to z. So I'm starting with just the sum of two logs, right, this part. And in order to sort of do what I'm going to do, I'm going to set it equal to some other letter, z. I'm going to say, all right, that's a thing. I'm going to name it z. Now I can do b as a base on both sides, right? So because that's a one-to-one function, I can do that. That's fine. So on the left, I have b to the all of this stuff, log base b of x plus log base b of y. On the right, I have b to the z, okay? Now, I can then take log base b of both sides. This is sort of a weird thing to do, right? Because I would take log base b of b to some stuff, and that cancels. And in fact, that's what happens on the right-hand side here, right? So on the right-hand side, I took log base b of b to the z, canceled out the b's, I'm back down to z. On the left, for reasons, which I'll get to, I just left it as is. So this is log base b of b to the log base b of x plus log base b of y. I could cancel those, but I'm not for a reason. So to be very clear, that right-hand side is using this idea that log base b of b to the z equals z. Okay. Now, I can take that whole inside bit on the left, this b to the log base b of x plus log base b of y. I can make that as a product of two terms. And this is because I'm using that fact that if I have exponent, like if I have b to the a plus c, that's b to the a times b to the c, right? Like if I have addition in an exponent, I can make that as a multiplication of the bases. So that's what's happening right here, okay? So I went from that addition to this multiplication. But each of these things, right, b to the log base b of x and b to the log base b of y, those are both b to the log base b of something, right? Which means that it cancels down to that something, meaning that this inside actually cancels down to log base b of xy. On the right, I have z, but remember z is log base b of x plus log base b of y, which gets me that the log base p of a product is the sum. So this is the product to sum sort of property saying that if I have a product inside the log, that's equivalent to having a sum outside the log. Right? So the general property for property 1 is saying that if I have log of xy, that's log of x plus log of y. Okay? If you didn't follow that, it's not a big deal. The actual property is the only thing you need to know at the end. But the The point I want to get across, even if you're not following step by step, is that this actually is a consequence of property 0. It's a consequence of how they're defined. It's not something that we're sort of just saying is true, or we're just sort of defining to be a rule or something. It sort of has to be true in order for the logs to be consistent, to be an actual thing that works. Okay? All right. Property 2. So if we have log base b of something to a power, so like something like 4 to the cube, like 4 to the third or 4 cubed, I can think about that as log base b of 4 times 4 times 4. But this is just a product, right? And according to property 1, I can split that up. I can say, okay, product inside is sum outside, so that's log of 4 plus log of 4 plus log of 4, which is really just 3 times log base b of 4, which if you'll notice, that 3 is the power, which makes sense because that's how many times it multiplied, which is how many times it's sort of split up. And so the sort of takeaway here is that if I have log of something to a power, I can take that power and move it in front, right? And again, this follows immediately from property 1. This isn't something I'm defining out of nowhere or I'm claiming sort of by fiat that it must work. This is something that has to be true in order for logs to actually work as a thing, okay? Property 3. So property 3, let's say we want to look at something like log base b of division. We want to look at something like, log of x over y. As an aside, I'm going to rewrite x over y in a particular way. So I'm going to rewrite this as x times 1 over y, right? So I can think of x over y as being x times 1 over y, or x times y to the minus 1. So really what I'm looking at when I'm looking at log of x over y is I'm looking at log of x times y to the minus 1. But again, this is log of a product, so I can make that into a sum, right? And then on the right-hand term, I have that negative 1 as a power, so I can pull that out front. But this gives me sort of my property part, which is that I'm going to now see, right, I went from log of x over y to becoming log of x minus log of y. Or sort of another way of thinking about this is that if I have log of something divided by the thing, divided by something else, then that's the log of whatever's in the top minus the log of whatever's in the bottom. Again, following from the other properties, so this is a thing that has to be true, not something that's just defined to be true. So those are, to be clear, those are sort of the 3 properties that you need to know, all of which come eventually from property 0, because property 0 gives you property 1, property 1 gives you sort of 2 and most of 3, and then property 2 gives you the rest of 3. So they sort of all filter down. But there are common ways that these properties show up, and sometimes these are also given as properties, which I think is insane, because I'm all about sort of memorizing or sort of learning a minimal amount of information that gives you everything you need. So these are the 3 things that yeah, you could get them from property 0. You could figure them out from the definition, but chances are you're not going to want to, and it's sort of not obvious how to do that without sort of having done it a bunch. So these 3 things I would say are the ones that you want to sort of remember the properties for. These next ones, though, really do come immediately from these properties. So things like log base b of 1 is 0. But really, if you think about 1, right, I could just write 1 as b to the 0. Right, because b to the 0 is 1, and then log base b and b to the 0, those b's cancel, and I get just 0. So this is literally just that property 0 up here, where x is 0. That's all that is, right? Log base b of b is 1. Again, same thing, right? This is literally just that same property 0, this bit here, where instead x is 1, right? So again, there's no reason to sort of memorize this as a different property. It really is just that thing, but I'm plugging in 1 instead of 0 or some other number. Last but not least, these 2 different things, this log base b of x to the minus 1, or equivalently log base b of 1 over x, either one of these things shows up sort of a lot for various reasons in various sort of math courses, especially in Calc 1. So you'll see something like this a bunch of times, and it turns out that these are both just negative log base b of x, but that's really just property 2 in disguise, right? So again, sometimes these are presented as additional things to memorize or whatever, which is crazy because it really is just applying property 2, realizing that if I have 1 over that thing, that's the same as using a negative 1 power, but powers can go in front. and that's just -1 times log base b of x. Okay, so the common ways these things show up, I'm mentioning these very explicitly because sometimes these are properties that are given depending on sort of your background, your algebra classes or whatever. You might have been given these things as things to memorize, and you really don't need to memorize these things. Don't try to recall them as facts. Try to use your sort of other properties, some smaller set of stuff you need to remember. Use those things to figure out what they are, because it's hopefully very quick and straightforward to get those from the original properties. Okay. All right, so what do we do? Well, we went through the properties of logarithms, right? So we went through that sort of property 0, the definition of the logarithm. Using that, we got that if you have a log of a product, you can write that as the sum of the logs. Then we used that part to get that if you have sort of log of something to a power, you can take that power and put it sort of in front of the logarithm. And then we had the log of division you can do as the difference, right? The log of the top minus the log of the stuff in the bottom. Those are sort of your 3, 4, if you want to count the definition, properties that actually sort of are the minimal set you want to remember, because actually deriving them, as you saw, was sort of weird and maybe not something obvious, but like the result is there. And then we talked about the sort of common ways they show up, things like logs. Log for any base of 1 is 0. Log of any base of that base is 1. And if you have log of like 1 over x or x to the minus 1, that's just doing negative log of x. As a comment here, I want to also point out that everything we did was for log base b, right? But that means that it works for any base at all. And in particular, it works for natural logs. So everything we said, right, and we sort of mentioned this when we talked about natural logs for a moment, but everything we said also applies to natural logs. This isn't a separate thing you have to remember for natural logs. It works for all logs, which include natural logs, right? So it's just the one set of properties for everything, natural logs and logs of other bases. Okay, so that is that.